We are going to cover spanning tree. ING tree protocol. But why spanning tree first of all? Okay. Let's take the switch. Switch 1. How many ports? Port P1, port P2. Port P1 and port P2. This is further connected to another switch. Switch 2. Right. What is here? On port P3, we have a switch. We have a PC. Okay. On this switch also, what is this? Port P1, port P2. This is another PC. Let's put it PC2. MAC address A, MAC address B. Okay?
Yes.
Let us add another switch here. Switch 3. Port P1, port P2. What is this? PC3. MAC address C. Right. Drag and drop like this for clarity. Port P2, PC2, right?
Yes.
MAC address B. Let's make this port P1 here. How many switches? 3 switches. Switch 3, switch 1, switch 2.
Yes.
Or you can have switch 1, switch 2, switch 3, doesn't matter, it's just numbered.
Yes.
So what do we have here? 2 ports. We have currently on switch 3, 2 ports are active. Right?
Yes.
This port is active because PC3 is connected to it. PC3 is MAC address is C. And PC3 is turned on. So this is active. On this side, port P1 is connected to switch 1. Similarly, P1, P2, P3 on switch 1. P1 is connected to switch 3. P3 is connected to switch PC1. P2 is connected to switch 2. Likewise, switch 2 has 2 ports P1, P2. Connection like that. MAC address was PC3 is C, PC1 is A, and PC2 is B. Right. Now let's walk through what happens if PC3 wants to send something to PC2. Source MAC,
C.
DMAC.
B.
What is this? For
Switch 3.
switch 3. MAC table for
Switch 1.
switch 1. What is this? MAC table for
Switch 2.
switch 2, right? So, again starting PC3 wanting to send to PC2. Source MAC C,
Yes.
destination MAC B. Forms the frame,
Yes, sir.
send it out to the wire.
Yes, sir.
Switch 3 receives it,
Yes.
checks the source MAC address of the frame.
Yes.
That is C.
C.
Checks if it is active. Not there, learns it.
C at P2.
C at P2. Second step, looks at the destination MAC of the frame, which is B.
B.
Checks it in the MAC table. Is it there? No. What does it do? Flood it. Receives at the switch. which does what? Check the source MAC address of the frame,
Yes.
which is C. Checks it in the MAC table, not there.
Not there. C on P1.
On P1. Checks the destination MAC address, which is B. Check the destination MAC address, which is B. It's not in the MAC table. So what does it do?
Flex.
To P3 and P2.
Yes.
PC1 receives the frame, checks compares the destination MAC address of the frame, which is B, to its own MAC address. Doesn't match, discards it. Continuing on this part, the frame arrives here. Where? On port P1 of switch 2.
Yes.
Switch 2 again does what? Checks the source MAC address of the frame, which is C.
Yes.
Is it in the MAC table?
No.
No. C
On P1.
on P1. Checks the destination MAC address of the frame, which is B.
It's not.
Is it there on MAC table? No. It will flood it. PC2 will receive it.
Yes.
And what will happen? It will check the destination MAC
With
of the frame, which is B, compare it with itself,
Yes.
it matches, it keeps it or retains it,
Yes.
accepts it. Very good. We all know this thing. Now what happens in this case is, just in case, if there is a link failure. Let's say this link fails. What happens if this link fails? Here, there is a failure. Then basically your LAN, this was one LAN by the way?
Yes.
This was one LAN.
Yes.
Your LAN is divided, is broken into two parts.
Okay.
Yes or no?
Yes.
Into what two parts? This is one part and this is another part. Yes or no?
Yes, sir.
So this part is isolated from that part,
Yes, sir.
or we can say that part is isolated from this part.
Yes, sir.
So in that case, PC3 cannot communicate to PC2. Neither can PC3 communicate with PC1. Only PC1 can communicate to PC2.
Yes.
So in this case, what we have to do is we have to give a alternate path. Keep an alternate path. Right. This was the path, only one path.
Yes.
So what we do is we provide an alternate path. We connect this to this. Right?
Yes, sir.
Okay. Now let us walk through this again. If without this failure there were two paths. Right? So what I am saying is we don't have to wait for this to break to provide an alternate path. We should always have an alternate path. Right? So without breaking, right, where there was only one path, we had studied this, how the frame would move. We had studied that, right?
Yes, sir.
Now let's study it again
Yes.
when there are two paths. Starting from the beginning. Right? Assuming there is nothing here. Okay? These MAC tables are empty. Right? Let's study this path when we had these two paths. We had these two paths. Switches operate on what layer? Layer 2, data link layer.
Yes, sir.
They function based on MAC addresses.
Yes.
Do they change anything
No.
when the frame goes through? Any change in the frame? No. They just read the source MAC address and destination MAC address and make the decision based on that. Okay, so we are back here. It's not isolated. Now we have two parts. Of course, when we do something, we want to do something extra, there is some drawback of it also. So we saw the drawback when there was only one link. There was only one link, right? One connection. When there was only one path, right? So we saw the drawback. What was the drawback? If something breaks, when the other, there is nothing, no alternate path. So you are all isolated.
Yes.
Now we have to see, we are connecting this thing. But there may be some problem with this part also, right? Everything comes with a positive and negative characteristics. So now, let's start over. PC3 wants to send to PC2.
Okay.
Source MAC address C, destination MAC address B. Forms the frame,
Yes.
sends it to the switch.
Switch.
Switch checks the source MAC address. What is source MAC address? C.
C.
Not in the MAC table,
Yeah.
learns it. right? Or on port P2. Checks the destination MAC address.
It's not there.
What is that? B. Is it in the MAC table? No.
No.
Floods it. Where? Here and
Here.
here.
Yes, sir.
Okay. Let's follow this path first of all. Let's follow this path. What happens here in this case? The frame is received here. Which one checks the source MAC address?
Yes.
Which is
C.
C. Not in the MAC table. Learns it.
C. P.
P1. Checks the destination MAC address.
B. B.
B. Is it in the MAC table? No. Floods it here and here.
Yes, sir.
PC1 receives it, checks the destination MAC address to be B, compares it with itself, A does not match, discards it. Continue here. The frame comes here. Source MAC,
C. C. C.
C, destination MAC, B. Switch to checks it, right? Switch to checks it. Okay.
Yes.
But before we go there, let's take this path also. Frame is being received here also.
Yes.
Right? Frame is being received here also. So what are we going to do? We are going to pay attention a little bit. One thing at a time. Right? One thing. So we are on this, we are going to have the focus on the switch. What are we going to have? Focus on the switch. We will pay attention on the switch. How it is going to react when a frame reaches it. From two angles. Right?
Yes.
We are going to take two isolated situations when the frame is coming from here and when the frame is coming from here. One case at a time. We will first ignore this and just say that this frame is coming from here and there is a path here and here. Second case we are going to say, okay, this is coming here, this is not coming, right? And then we are going to see. The third case is then once we have understood the isolated case, right? First case and second case, then we are going to combine both of them and then say how is the switch really going to act. You get the point?
Yes, sir.
First case was, we will say, oh, there was no frame coming from here, and how it would have reacted,
Yes.
right?
Yes, sir.
And second case, the frame is coming from here, no frame coming from here. And then in reality, what is happening? Frame is coming from both directions. Then that is where the reality for the switch. Okay. So the frame coming from here first case. What is the source MAC address?
C.
C. Destination MAC address?
B. B. B.
B. So is it in the MAC table?
No.
No.
B.
It will
B1.
P1. Destination MAC address?
B.
B. Is it in the MAC table?
No.
Flooded? Here
Yes, sir.
and here.
Yes, sir. Yes, sir.
Alright?
Yes, sir.
In this case, forget about we will not study this part as of now. But the frame reaches here.
Yes, sir.
Destination MAC address? B.
B.
Matches the MAC address, it accepts it.
Yes.
Good? Fine?
Yes, sir.
Done?
Yes, sir.
This was the case 1 when we only took into consideration this part, right? I love this.
Yes.
Frame coming from here.
Yes.
Source MAC address,
C.
destination MAC address,
B.
B. Is C in the MAC table?
No.
No. C,
Yes.
MAC table, what is this? P3.
P3. C1, P3.
P3. Learned?
Yes.
Destination MAC address,
B.
B. Not in the MAC table,
Yes.
do what?
Flooding.
Flooding where? Here
P1.
and here.
P1.
Right? Let's ignore this for a second.
Okay.
It goes here. Right or not?
Yes.
It goes there. PC2 checks the destination MAC address, matches it, and it's happy. So either way, in either path, whether this path or this path, PC2 is getting the frame.
Yes.
So, right? If this fails, still it will get it from this side. If this fails, then this will get it from this side. So this clear?
Yes, sir.
Now let's go back to the combining the two scenarios. Which one? Scenario 1 coming from here also and from here also. Let's see what happens. Let's stop this. Let's assume that the frame from here reaches first. Reaches first. Okay. So, by the way, before I go there, so now we are clear, right? Why do we put redundancy? The big question is, right? Why do we put redundancy? This was the only part. Which was the only part? This was the only part. Right? And for this any failure here and anything to be happening, what do? We provided a redundant path. So in this case, even this fails. If this failed, is our network isolated? No. Because
Yeah.
switch 3 is connected to switch 2 and switch 2 is connected to switch 1. So we still have a connectivity from PC3 to PC1
Yes, sir.
and PC3 to
PC2.
PC2,
Yes, sir.
right? We have provided a redundant path. If, how about, if we, instead of that failure, if it failed here, still good?
Yes, sir.
Because PC1 has connectivity to PC3,
Yes, sir.
PC3 has connectivity to PC2 via this path,
Yes, sir.
and PC1 has connectivity with PC2 using this path.
Yes, sir.
So we are happy with that part.
Yes, sir.
Redundancy has done the path.
Yes, sir.
But now with the added redundancy, what is happening? What is happening is exactly what we are going to check now. Right? So now we have provided redundancy, but there is no failure in the link. So what did we just cover? We covered two things. First thing is, if there is no redundancy, then something goes bad. If there is no redundancy, what? If there is no redundancy here, and if something breaks here or here, then isolation happens. Right? Okay, that we have cleared the concept. That's the reason why. First question was, why do we put redundancy? We put redundancy so that if there is a failure of somewhere, then we can use a redundant path, right? And we have seen that by putting a redundant path, if there is a failure here or here, the entire connection is there.
Yes.
Right? And what are we talking about? One failure, not multiple failures. Right? One failure. So by providing a redundant path, right, we are isolating that problem of, we are reducing the probability of isolation. Done?
Yes, sir.
Now, but in normal cases, if there is no failure and there is redundancy provided, what is the harm? Right? What is the harm? You get my point? What I am
Yes,
saying?
sir.
What is the harm? Let's see. And this one, PC3. We have provided a redundant path, there is no failure. All are good.
Yes, sir.
All are good. What is happening now? Frame comes from here and frame comes from here also.
Yes.
Which frame? Which PC3 have generated for PC2? In the source MAC address C to the destination MAC address B. So the frame has traveled from here and got flooded here. Similarly, it is flooded here.
Yes.
Now the frame, let's consider this frame coming from here first. Port P3
Yes, sir.
received here.
Yes, sir.
It will learn the MAC address.
Yes, sir.
Right? It will say, oh, source MAC address C on port P3
Three.
and let me flood it in this direction.
Yes, sir.
This is happy that I got it.
Yes, sir.
Same frame coming from here.
Yes.
You'll say, oh, what is the source MAC address?
C.
C. And on what port am I learning it? P1. Oh, that means there is a MAC move.
Yes.
Right? Now, the latest information you will consider, right? So it will, oh, let me clear it. Port P1. And then take the destination MAC address, which is
B.
B. Is B in the MAC table? No. Let me flood it here. This is again happy. But now this frame is going to call here, go here.
Yes.
Huh?
Yes.
This will say, oh, switch 3, I am getting a frame from source MAC address C and destination MAC address
B.
B. So I have to rewrite this. C was previously P2
On P2.
and now it will become P1.
Yes.
Now it is becoming what? P3.
P3.
Rewrite it. MAC move.
Yes, sir.
Right? Similarly, this frame is sent here.
Okay.
What is happening here? With the source MAC address C. Huh?
Yes.
Destination MAC address B.
B.
Oh, it says, oh,
C on P2.
again MAC move.
Yes, sir.
And then flooded here.
Yes.
So this basically the frame which was positioned this way in this direction is doing what? Is doing what? It's basically the frame which was sent in this direction initially, right?
Yes.
Was flooded here. Huh?
Yes.
When it reached here, it got flooded back here, came back here, right? and similarly it was flooded here. Okay, and likewise the frame that was sent out here, initial flooding, reached here, was sent out here, sent out here, sent out here, sent out here. So what do we see? We are seeing
Frame is moving from
and what are we seeing? What are we seeing here? We are seeing something like this pattern. Hmm? Can you say like this again? Hmm? Can you say again like this?
Yes.
What is this? A loop. And similarly, what is this? We can form like this also.
Yes, sir.
So what do we call them? Multiple loops in clockwise and counterclockwise direction.
Okay.
Yes.
Loops in clockwise and counterclockwise direction. Right? And further, what is happening here? Continuously Mach move on this one, and this one, all three. Mach move.
Yes, sir.
Right? And imagine this thing happening so fast. It happens very fast. Communication is so fast. Wires and these equipment, it's not slow. So what will happen is, right? If just imagine I am being a switch. I have two ports, right? One frame tells me, oh, this is here. One frame tells me this is here. So my memory will get corrupted,
Yes, sir.
right? So that is the answer. So by loops, this is a loop.
Yes.
By providing redundancy, what is the harm? What is the harm? Harm is that loops occur. What occur? Loops occur. Loops will occur. And which type of loops will occur? Clockwise and counterclockwise. Further, what will these loops result in? These will result in Mach move operations on all the switches. Right? Mach move operation. And what will result in the Mach move? The memory corruption may happen. Right? Because what are we saying? We are saying that every switch is an intelligent device. Why? Because it maintains a Mach table. Right? Now your Mach table is getting corrupted because it's being told this side, this side, this side, this side. And Mach table may get corrupted. Right? Because there is a limit till it, right? Till which it can sustain. After that it may crash. And then, so Mach table may get corrupted. Right? Because of Mach moves, continuous Mach moves. Clear on that part?
Yes, sir.
So let me recall all the things. First thing was, why do we need redundancy? First of all, why do we need redundancy? We need redundancy because if the primary path fails, then there should be a secondary path, so that a network does not get isolated. A part of the network which was isolated does not get isolated.
Yes.
But then, when you are providing a redundancy between two paths, what is the possibility? That loops may occur. And because the loops may occur, what will happen? Your Mach move may happen.
Yes, sir.
Mach move may happen, then result in what? Result in what? Memory corruption.
Memory corruption.
Right? That is what. Further, now what is happening is, if you see this, did PC3 send two different frames in two different directions? One for here, one for here? No. It didn't intend to do that. Who sent it? The switch.
Switch.
Switch flooded it.
Yes.
So who made replicas? Who made two copies?
Switch.
Switch made two copies. Right. Now it sends the two copies. This one is again going to make a copy. Two copies.
Yes, sir.
It comes here. It is going to make two copies.
Yes, sir.
Right. And in this way, what is happening? The number of frames are increasing over the network. What is happening? The number of frames is increasing. Right. So yes, they are reaching the destination, but they are still flooding. Every time a frame comes in, another copy is created, right? It's created and sent out. Every time it's happening. And this is what is happening in both directions. Not only they are being flooded in clockwise and anti-clockwise direction, but multiple copies are created every time.
Yes, sir.
Every time it goes through a switch, another copy is created.
Yes.
Right? So initially when there was only one frame in clockwise direction, now next time there will be two frames. Next time there will be three frames. Now the three frames, when they go through it again, there will be copies of 3 to 6, 6 to 12, 12 to 24. Imagine that. So soon what will happen? The whole entire bandwidth will get exhausted.
Yes.
Right?
Yes.
So entire bandwidth will get exhausted. So let's recap now. First of all, why do we need redundancy? We need redundancy to avoid isolation of networks in case of failure.
Yes. Yes.
But in case there is no failure and we have provided, again, we are just thinking ahead that there might be a failure, so we need to be ready.
Yes.
Right? We are not going to dig a well when there is fire in the house. Right? So that's why we have made arrangements for redundancy. That in case there is a failure, then we should be taking care.
Yes.
Right? There should be alternate paths. Right? But now if there is no failure and redundancy is there, then what will happen? This might happen.
Yes.
This might happen. Right? Now this is the case when the destination is not known in the map table. Destination is not known in the map table. That's why flooding is happening. Had those MAC addresses been known, then will the flooding happen? No.
No.
Right?
They
They will
flow in the
go.
correct path.
Right? Further, if there is a broadcast frame sent, then still flooding will happen?
Yes, sir.
You cannot do anything. Right? Broadcast frame is always flooded.
Yes.
Always flooded, right? So, that's the reason we have covered why do we need redundancy, what happens without redundancy. Now we have covered what happens in case there is redundancy and no failure.
Yes.
So loops will occur. Which types of loops? Clockwise and anti-clockwise. Why will the loops occur? If the destination, if the frame is a unicast, correct? If the frame is a unicast and the destination is not in the map table. That is case 1.
Yes.
Loops will occur
Yes.
clockwise and anti-clockwise.
Anti-clockwise.
Also, loops will occur if the destination is the broadcast,
Yes.
right? Because the broadcast address will never be in the map table,
Yes.
so it will again be flooded in the clockwise and anti-clockwise direction.
Yes.
And now, because this is getting flooded, right? Okay, step 1. Unknown unicast will be flooded
Yes.
and broadcast will be flooded
Yes.
in both directions.
Yes, sir.
And when the flooding is happening, irrespective of these two cases, what is happening? Two things are happening. What? One is the continuous map move,
Yes, sir.
right? And the other thing is
Loops in the over.
exhausting of the bandwidth,
Okay. Yes.
right? And because of the bandwidth, what will happen? Whatever interesting data was also going through will also shut down. Because if somebody is going to choke your bandwidth, then the interesting traffic will also go down.
Yes.
And the case 1 was because of the continuous map move, the map table may get corrupted,
Correct.
right? And the switch may crash.
Yes.
Okay.
Okay. Yes.
Alright, so this is clear. Let's try to make a rough block diagram about this. Right? Because of this, what is happening? Because of this, what is happening? Let's try to do that.